let's move to the second part, the last part of our lecture today. Okay, so that will be on the hypothesis testing for two population means and two population proportion. So uh, all the concepts are still the same. Okay, for the two population means, okay, we are still talking about the same rejection region and critical value and what we call the statement of hypothesis, whether you're null and alternative of your statement. So if let's say we are talking about the uh, null statement, mu1 minus mu2 is equal to the hypothesized value. Now, this hypothesized value can be 0 or can be any value defined. Okay, based on your question. So it can be 0. How it can be 0? You can identify based on the given condition in your questions. Okay, so you somehow you will know how it becomes 0, how it becomes with certain value. And of course, the alternative, if you are talking about one tail test, so mu1 minus mu2 is less than mu naught. Okay, your mu naught will be 0 or could be any value. Okay, what does this mean? Okay, if mu1 minus mu2 is equal to 0, if let's say mu1 minus mu2 is equal to 0, mu1 minus mu2 is less than 0. If equal to 0 means that the value of mu1 is equal to mu2. If mu1 minus mu2 is less than 0 means that mu1 is larger than here, mu1 is larger than mu2. Okay, what about mu1 minus mu2 greater than 0? Sorry, mu1 minus mu2 less than 0 means that mu1 is less than 0. Sorry, because you will get negative value, right? So mu1 minus mu2, for example, 50 minus 52, definitely you will get negative 2. So means that mu1 is smaller than mu2. Right. If mu1 is minus mu2 is greater than 0, means that mu1, okay, is actually greater than mu2. So you need to understand what does these phrases mean. Okay. Okay, that's why we have this particular statement. Could be either one of these will be your statement of your hypothesis test. Now, for this one, this will be left tail test, this one will be right tail test, this one will be two tail test. And the rejection region, as always, it reflects the tail of your distribution, Z distribution. If left right tail test, then you are talking about alpha here. If you are talking about left tail test, you are talking about alpha here. If you're talking about two tail test, we are talking about these two rejection regions, so alpha over 2. Okay, so that will be Z alpha over 2, Z alpha over 2, this one negative. Okay, the same goes to T distribution. Okay, exactly the same. It's just that you are using your T distribution. Now, again, what will be the condition for two population means? Again, you will need to remember the condition of your sigma 1 and sigma 2. If it is known or if it is unknown, if it is greater than 30, if it is greater than less than 30. Okay, and then finally, it's either your sigma 1 is not equal to sigma 2 or sigma 1 equal to sigma 2 and so on and so forth. So there will be a different formula that you will need to apply for different conditions. Now, let's look first at the hypothesis testing for the difference between two population means. Now, we can see that a particular example on page 98. Okay, on page 98. So the mean lifetime of 30 bulbs produced by company A is 48 hours. Okay, The mean lifetime, so you are talking about company A, and then you are talking about company B. So company A, mean lifetime of 30 bucks. So then you know N1 is 30, is 48 hours. The mean lifetime, so the mean is 48 hours. And then the mean lifetime of 30 bucks, 35 bucks. So then the second sample is 35. And then the mean is equal to 50 hours. Okay. If the standard deviation of all bucks, so please class, look at the statement here. If the standard deviation of all bucks produced by company A is 3 hours, this reflect your sigma because all bulk reflect to your population. In this case, sigma is known. Okay, known sigma, that is sigma equal to 3. Okay, that would be for sigma 1, sigma 2, 3.5. Okay, test at 1% significant level, so alpha is equal to 0.01. Okay, so that would be among the information that you need to understand and you need to know how to interpret from the given question. Okay, so let's begin with the solution. The first one would be your claim of your null and alternative. So null, alternative. So look at your further sentences. Now, test at 1% significant level that the mean lifetime of bulk produced by company A is less than company B. Or in your textbook is using shorter. Okay, shorter. So what does this mean? So mu1, so you are talking about mean of company A is less than mu than company B. So if it is less than, it means that you are going to use this, right? This one. Less than. Okay. So in this case, it will be mu 1, since I'm using 1 and 2. So mu1 minus mu 2 is less than 0. And as usual, the null will always be equal to. So mu1 minus mu2 equal to 0. And this will be our P. Okay. So second step, if you are using your traditional method, so your test statistic, sorry, your critical value. Okay, so your critical value, since we are dealing with one tail test, that is left tail test. So Z alpha, okay, n greater than 30. Okay, so sigma known. So Z alpha over 2, sorry, Z alpha only, because one tail test. So Z alpha is equal to Z 0.01, which is given by 2.3263. Okay, but since we are dealing with left tail test, so this become negative. Okay, so third, Z test statistic. So Z test can be obtained by, so it will be X bar 1 minus X bar 2 minus mu 1 minus mu 2 divided by square root of sigma 1 squared over n1 plus sigma 2 squared over n2. So if we put all the values in, so you will get 48 minus 50 minus mu1 minus mu2 is equal to 0. So equal to 0 divided by square root of 3 squared over 30 plus 3.5 squared over 35. And then you will get negative 2.481. Okay, decision. Okay, so your decision, if I'm using my sketch, okay, my critical value is at the negative 2.3263. That would be your negative Z alpha. And then this is your alpha. Okay, your alpha is equal to 0.01. Now, look at your test statistic. What is the value? The value is negative 2.481, which is smaller than your critical value. So this is negative 2.481. So since the value falls in the rejection region, then we can make a division, reject, null hypothesis. Okay, so when we reject the null hypothesis, then we can say that number 5, what will be our conclusion? So our conclusion would be, okay, we have, okay, remember class, our claim is at the alternative, means that we need to support. Okay, now we reject the null hypothesis, then we accept the claim of the claim, which means we have sufficient evidence to support. So we have sufficient evidence to support our claim, okay, that the mean lifetime of bulbs produced by company A is shorter than company B. Okay, so that's how we make the decision. Okay, any question, class? That would be how to perform the hypothesis test using for two population mean using the traditional method. You can try using the p-value methods on your own. Okay, so let us look at one of the exercise before we can end our class with the hypothesis testing for two population proportion. Okay, so let's look at the question, exercise 3.8. So you can find that on page 99. Okay, 99. A sample of 60 mates from country A earn an average of 300 per week within a standard deviation of 16. So we are talking about country A. Okay, country A, how many? 60. And then what is the average earning? Average earning is 300. And we have country B. Okay, and then we are talking about the same sample size. N2 is equal to 60. From country B, earn an average of 250. So X bar 2, 250 per week. With standard deviation, so the standard deviation S equal to, S1 is equal to 16. S2 is equal to 18. Okay, now what else should you test at 5% significant level that country A meets average earning exceed country B by more than 40 RM per week. So you need to test for mu A exceed, so greater than mu B by 50, sorry, 40. So the way you write can be this way. So mu A minus mu B is greater than 40. So when you deduct mean or average earning of country A with country B, so you should get more than 40 per week. So this will need to be checked. So let's begin with this solution. Okay, so solution. So first step, the statement. The statement will always be mu1 minus mu b. Okay. So in this case, since the hypothesized value is 40, so you have 40 here. Alternative would be mu1 minus mu2 is greater than 40. Okay. Now, what is our claim? This is our claim. So H alternative will be our claim. Second, find the critical value. Since we are dealing with right tail test, so right tail test. So we are dealing with n greater than 30. Okay, so n greater than 30, m1 and 2 greater than 30. What else? Assume population variances are not equal. So sigma 1 and sigma 2 are not equal. Okay, unknown sigma. Because we don't know. Okay, unknown sigma 1 and sigma 2. So which one that we need to use? Okay, so unknown sigma greater than 30, not equal. So we are using this. Okay, so we are using that particular formula. So now for the right tail test, so Z alpha is 0.05. So what is your Z alpha 0.05 plus 0.05 will be 1.6449, right? 6449. Number 3, Z test. So this is where we need to consider this. Okay. So Z test is equal to x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by square root of sigma 1. Okay, S1 divided by N1. So you have S1 squared over N1 plus S2 squared over N2. So this one would be, so you have 300 plus 250 minus 40 divided by square root of 16 squared over 60 plus 18 squared over 60. So can someone calculate? Okay. 300 minus 250 minus 40 divided by 16 squared divided by 60 plus 18 squared divided by 60. So you will get 3.216. Okay. Is it correct?
Yes.
3.216. Okay. Thank you. So then we need to compare for our division. So number 4, division. So for the division, let's say we are using the sketch of our distribution. We write tail test. So our critical value is, this one is 1.6449. And this is our rejection region, alpha. And then this is our non-rejection region. And look for the test that is Z test. So Z test is 3.216, which is larger than this one. So 3.216 falls in the rejection region. So we can say reject null hypothesis. Okay, so reject null hypothesis. Okay, so then what will be your decision? So that's 3.8. Number 2. So what will be your decision? Okay, can someone make a decision for me, class? Can someone make decision for me? Huh? We are 95% confident that uh, that the that country A makes mean earning, okay, exceed country B makes mean earning. No. We have to say sufficient or insufficient, right? We are 95. We are. Okay, let me. 90. We are. We have. Okay. We have. Okay, now the claim is at the alternative, and yet we reject this. Reject now hypothesis. So we have sufficient evidence to support our claim. Okay. So we have sufficient evidence to support our claim that country A makes mean earning exceed country B mean earning by more than RM40 per week. Okay, so that would be your conclusion for this particular hypothesis testing. Any questions so far, class? Class?
No question.
Okay, thank you. Then we go to the last part, hypothesis testing for the difference between two population proportion. Okay, so for this part, okay, so exactly the same except that the statement of your now and alternative will be referring to the difference between the first and second population proportion. And we are going to compare with the hypothesized value of your proportion. It's either 0 or any other defined value, okay, in your question. And then the rest, I think almost the same. It's just that you are going to have this particular what we call consideration for your hypothesis testing for two proportion. Now let us look at the first example. Okay, P1 hat, P2 hat. I think at this point it will be no problem. It's just that for the last part will be finding the overall proportion. So this one is overall proportion. So for the overall proportion, you are going to add the x1 and x2 divided by the sample size from both samples. Okay, that's it. Now, for hypothesis testing, you look at example 3.12 on page 99. Okay, a researcher wanted to estimate the difference between percentages of two skincare users who will never switch to another skincare. In a sample of 500 of skincare A, so you are talking about skincare A, you have N1 is equal to 500. Okay, 100 say, so your X1 is equal to 100. That they will never switch to another skincare. Another sample of 400 who are using skincare B, so skincare B, N2 is equal to 400. Out of 400, okay, 68 says that they will never switch to another skincare. So X2 equal to 68. Okay, so then at 1% significant level, can we conclude that the proportion of skincare A who will never switch to another skincare is higher than skincare B. Okay, so let's find the P1 hat, P2 hat, and the overall P hat. So P1 hat is equal to 100 over 500, which is equal to 0.2. Okay, P2 hat equal to 68 over 400. That will be equal to 0.17. The overall proportion, okay, P hat is equal to 100 plus 68 over 900 equal to 0.1867. Okay, now first step statement. Using the last sentence here, okay, so we know that P1 minus P2 is greater than. So let's begin with this. So P1 minus is higher than. So higher than P2. So this becomes P1 minus P2 is greater than 0. Okay. So that's why we have equal to 0 here. Alternative, P1 minus P2 greater than 0, which is the claim of your study. Now, second, critical value, CR. Critical value, alpha equal to 0.01. Okay, 0.01. So, since we are dealing with a right tail test, okay, so we know that Z 0.01 is given by 2.3263. Okay, and then the third one would be your test statistic, Z test. That would be P1 hat minus P2 hat minus P1 minus P2 divided by square root of, okay, square root of the overall proportion, right? So overall proportion is 0.1867 multiply with the 1 minus P, that will be 0.8133 multiply with 1 over 500 plus 1 over 400. Then I just put everything using the what we call the value. Okay, so it will be more safe time. Okay, so you have P1 hat minus P2 hat, that will be 0.2 minus 0.17, and then this is 0. Okay, this one is 0. So you will get here 1.148. Now, number 4, make division. Okay, make division using the distribution. So right tail test. So you have 2.3263 here, and this is your rejection region for alpha 0.01, and then your Z test is 1.148, which is smaller than your critical value, 1.148, fall in the non-rejection region. So we can say fail to reject null hypothesis. Okay, so fail to reject null hypothesis. So then number 5, conclusion. Okay, save time, refer to your book. So how can we say? Just to read it. There is insufficient evidence. Why insufficient? Since we fail to reject this, fail to reject null. Okay, so yet we know our claim is at the alternative, then we don't have enough evidence to support our claim. So that's why we conclude that we have insufficient evidence to reject the claim. That is, what is the claim? That is, okay, the proportion of skincare A user who will never switch to another skincare is higher than the proportion of skincare B users. So that will be your conclusion. Okay, so let's end our class with the question for the exercise of your hypothesis testing for two population proportion. Are you all with me, class? Are you all with me? Now, exercise 3.9. Okay, exercise 3.9. In a process to reduce the number of deaths due to dengue fever to district A and B, each consists of 150 who have developed symptoms of fever were taken as sample. People in district A are given a new medication in addition to the usual ones, but the people in district B are given only the usual medication. So we are talking about district A, district B. Okay, A with new medication, B common usual medication. So from here we know that district A N is involved by 150. Okay, people in district A, it is found that from district A and from district B, 120. Okay, so N2 is equal to 120. Okay. Okay, now it was found that from district A and from district B, 120 and 90. So please get the information correctly. Now, okay. N1 is 150. N2, both are having 150. X1 is 120. X2 is 90. Okay. Test the hypothesis. So test the hypothesis that, okay, new medication is better to cure the fever than the usual one using 5%. So you are testing that new medication is better to cure than the usual one. Means that if you are talking about the number of patients, means that the proportion of P1 must be greater than P2. This will say that new medication is good. Okay, new medication is better. Okay, so in this case, what happened is that, okay, so the first step would be the null statement would be, okay, your null statement will be P1 minus P2 is equal to 0. Then the alternative would be P1 minus P2 is greater than 0. Since we need to prove that the proportion of new medication is better than the old medication, the usual medication. So this is your claim. Okay. So let's find your P1 hat. So P1 hat would be 120 over 150. The P2 hat would be 90 over 150. Can someone calculate 120 divided by 150? What is the value? Is it 0.8?
Yes, 0.8.
Okay, 90 divided by 150, you will get 0.6, right?
0.6.
Okay, thank you. Then we have to find the overall proportion. So P hat would be 120 plus 90 over 150 plus 150. So directly calculate 120 plus 90 divided by 300. 0.7, right? Okay. So second, critical value, CR. So alpha is 0.05. And we are talking about right tail test. Right tail test. Okay. So Z 0.05 is given by what? 0.05. Even though I have crossed this one so many times, I still need to check. 0.05 is what? 0.05 is 1.6449, right? 1.6449. Third one, Z test. Okay, your Z test will be Z equal to the difference between P1 hat and P2 hat is this one. Okay, so 0.8 minus 0.6 minus the hypothesized value difference is 0 divided by square root of using this one 0.7 multiply with 0.3 multiply with 1 over 150 plus 1 over 150. Okay. So you will get 0.2 divided by what value at what is the denominator value? Square root 0.7 square root 1 multiply with 0.3 multiply with 1 over 150 plus 1 over 0.0529. You get 0.0529? You get this? Yes, so this one 0.2 divided by 0.053, you will get 3.77. Okay, 3.77, 3.7735. Okay, if I take 4 decimal points. So, number 4, division. Is it correct? 3.9, P value 3.78. Okay, so division. Okay, alpha 1.6449. Rejection region is over here. And you get 3.7. So 3.7, for example, 3.77 is here. So here we can make decision, reject null hypothesis. Okay, when we reject null, whereas we need to find evidence, so in this case, we find evidence to support our claim. Okay, so therefore, number 5, conclusion, we have sufficient evidence to support our claim that the new medication okay, is better to cure the fever than the usual ones at 5% significant level. Okay. Now you have another question over there. Use p-value method. Okay, and as additional exercise. So let's say if we are using our p-value method. Okay, p-value method. Okay, now for p-value method, we know that statement of hypothesis still the same. H now would be proportion, right? Okay, P1 minus P2. So we have P1 minus P2 equal to 0. Alternative, P1 minus P2 greater than 0. This is our plane. Okay. And then the second one would be find the z test. Second will be z test. That will be the one that we obtained just now is 3.77. Let's say 3.77. Okay. Now we need to find using 3.77 what is our p-value. Okay. So z test is 3.77. So if we draw, okay, right tail test, okay, z test, the one that we calculate just now is 3.77. We need to find what is the probability here. And this is what we call our p value. Okay. And we know that using our first table, okay, half of this is 0.5, right? If this is where z equal to 0. Now look at your find for the probability of pz between 0 until 3.77. So look at your first table. So let us look at our z first table. Okay, z first table, this one. We are looking for z is equal to 3.77. So look for 3.77. 377. 0, 1, 2, 3, 4, 5, 6, 7. Is this correct? Okay, so this one is for z equal to 3.77. It's 0.49999. Okay, so in this case, it is 0.4999. Okay, so how do I find p-value? Is 0.5 minus 0.4999. That will be what? 0.0001, right? Okay, so that will be 0.0001. Okay, now how to make a decision? My alpha is equal to 0. What is my alpha just now? 0.05. Okay, 0.05 and here lah. Okay, number 4, decision. Okay, in order to make decision, alpha will be compared with p-value. Okay, alpha is 0.05. Okay, what is our p-value? P-value is 0.0001, which is alpha is greater than our p-value. Then in this case, we are going to what? We are going to fail to reject. Why? If you can imagine, where is our alpha? So our alpha is actually greater in terms of the probability value, which is larger than that one. Okay, so for example, this is your alpha. So your alpha is 0.05, which is obviously larger than your p-value. So your p-value is inside your rejection region. So that's what, the p-value, do we reject, right? Okay, yes. We reject the null hypothesis. I'm really sorry. Okay, reject the null hypothesis. Okay, reject the null since p-value is alpha is larger than p-value. Reject null hypothesis. Okay, because obviously it falls in the rejection region. So conclusion, the same as above. Just now. Okay, so that's all for the hypothesis testing for two population proportion. So I believe we have almost complete our chapter 3. So class, start doing your what we call your tutorial questions. And for your tutorial questions, since you have too many tutorial questions, you can start doing some of them. And I may be asked you to submit your tutorial for the selected questions from tutorial 2. So last but not least, before we leave, do you have any questions?